All right, this is the Section 1, Topic 8 lesson, Part 1 on parallel and perpendicular lines. But before we get to this, we're going to do a review problem here. We're going to keep chipping away at partitioning lines. So here we go. Consider the directed line segment. Directed means when it says from A to Z, we're starting at A and going to Z when we're partitioning it, breaking it up into its pieces. So from A, -3, 1, so let's put that on our graph, to Z, which is at 3, 4, we'll put that on our graph. There we go. And use a straight edge. Use a sheet of folded paper here to be my straight edge. Connect them. All right, there we go. All right. Consider the directed line segment, and points L, M, and N are on segment A to Z. So L is at -1, 2. There it is. M is at 0, and that's 5/2 is 2.5. So 0, 2.5. There's M. And N is at 1, 3. Right here, I didn't draw my line real good. There we go. All right, so the point what partitions segment AZ into a 1-to-1 ratio. 1-to-1 means 1 here, 1 here. So how many total pieces do we have this broken up into? 2, and they are equal segments. So we're talking about 2 equal segments. Look at AZ, which of these points breaks it up into 2 equal segments? And that would be the middle point right here, point M. So M partitions this into a 1-to-1 ratio. All right, what point partitions it into a 1-to-2 ratio? All right, so 1 to 2 means how many equal portions? 3. So we need the point that breaks this up into 3 pieces, where 1 piece on the left and 2 segments, 2 of these on the right-hand side. So we're breaking it up into 1/3 and 2/3. So 3 total pieces, like this. 1 to 2. There we go. All right, so which of these points is about 1/3 of the way, or exactly 1/3 of the way from A on its way to Z? So if we look at L right here, let's look at this. If that's 1 piece, would this then be 2 pieces on this end over here? Well, to double check that, I mean, it looks correct. To check it, we can count. So stair steps here. This is to the right 2 and up 1, to the right 2 and up 1, to the right 2 and up 1, 3 equal stair steps on its way up. So this is 1 piece, and then these make up the other 2 pieces. So L is definitely the point that partitions AZ, segment AZ, into a 1-to-2 ratio. All right, so let's look at a 2-to-1 ratio. Well, that would mean you've got 2 parts to the left and 1 part to the right. So which point here leaves us with 2 of those equal segments to the left and 1 of the equal segments to the right? And probably it's going to be N, because we haven't used that one yet. So let's look at N. You can see 2 steps to the left and 1 step to the right. So a 2-to-1 ratio. So N partitions AZ into a 2-to-1 ratio. All right, what is the ratio of AL to AZ? So let's look at AL right here. And AZ is the whole thing. So talking about this portion right here, if this is 1 portion, then how many of those equal segments make up the whole thing? And we've seen that there are 3, right? 1, 2, 3. So if AL is 1, all of AZ is 3. So this would be 1. And look at this right here. That's 1. Let's do a different color here. 2, 3. There you go. 3 equal pieces. All right, so AL would be 1, AZ would be 3. This is part, and AZ was the whole thing. So this is a part to whole ratio. Most of the time we do a part to part ratio, but here you have a part to whole, so it's a 1 to 3 ratio. All right, we'll just keep plugging away at partitioning segments. All right, let's look at parallel and perpendicular lines. These lines are parallel. They have these nice little symbols right here that show us that, yep, truly they're parallel. Parallel. The symbol used to indicate parallel lines is this. These lines that have this nice little symbol right here, that right angle symbol, those are perpendicular. The symbol used to indicate perpendicular lines looks like an upside down T, but it looks like two lines that are perpendicular to each other. We've seen that earlier. Choose 2 points on each graph and use the slope formula to verify your answers. All right, let's look at the slope formula. You've seen this in algebra. It's the difference of the y's, which means that you're traveling in the y direction. So remember, your y-axis is this one. And when you look at how far you've moved in the y direction, you're going up and down. We usually call that rise. So even if you're going down first, that's a rise of a negative number. So it's a drop, but we say you're rising negative. And then these x's traveling in the x direction, we call that the run. So usually people recognize rise over run before they recognize the formula for finding slope. And we are not going to use the formula right now because we have pictures, and pictures make life so much better all the time. So use the slope formula to verify your answers. Choose 2 points on each graph. Okay, so let's go over to this graph right here and find 2 good points. They're a little hard to see. Let's pick that one and that one. There's another one there. They continue all the way down. I always start on the left-hand point. If I have to rise, that's fine, but it'll mean that I'm always running in a positive direction. So sometimes I drop and run, rise and run. But if you start with your left-hand point, run is always going to the right. It's always a positive number. That's kind of nice to have. So here we go. Rise down. Okay, I'm not rising. I'm actually dropping 2 and running 1. Dropping 2, running 1, dropping 2, running 1. So this has a slope of negative 2 over 1. Well, what's negative 2 over 1? That's just negative 2. All right, let's check the slope on this one. Here's a good point. Here's a good point. Okay, that looks about the same, doesn't it? Drop 2, run 1. So this also has a slope of negative 2. All right, so parallel lines, what do you notice about the slope? That's coming up. What do you notice about the slopes of the parallel lines? Slopes are the same. Sorry, we should have written here. Line 1, L1, has a slope of negative 2 over 1. That's negative 2. And L2 has a slope of negative 2 over 1. So they both had the same slopes. I think we're going to need that quite a bit later. All right, what do you notice about the slopes of the perpendicular lines? All right, so let's go look at these slopes. Now this one is going uphill. See the little car? He's going uphill, so that's a positive slope. This one is going downhill. And we always read our slopes left to right, like we read a book. We read words left to right. This little car is going downhill, that's going to be a negative slope. This one's going uphill, that's going to be a positive slope. Now pick 2 good points on the line. Okay. This is going up 2 and over 1. So this one has a slope of 2 over 1, which is 2. So line 3 has a slope of 2. And then let's look at what line 4 is. Okay. And there's a point right there, and there's a point right there. All right, start with your left-hand point, and it drops 1 and runs 2. So this one has a slope of negative 1/2. Drop 1, run 2. All right, what do you notice about the slopes of the perpendicular lines? Well, this was 2 over 1. If we look at it as 2 over 1, it's a little easier to see what happens here. 2 over 1 flips upside down to become 1/2. And this was positive, this was negative. So we have opposites, positives, negatives, right? And reciprocal. That's flip. So opposite signs flipped over upside down, and those are our perpendicular slopes. What happens if the lines are given in equation form instead of on a graph? Well, if that's the case, you're going to have to look at what the slope is. Slope-intercept form is very easy for finding slope. This is the slope, the coefficient on x. And so if we look at the slope, then we can see, if we put it in slope-intercept form, we can see what the slope is, and then we can just compare the two equations. So if you have two equations with the same slope, those have to be parallel. And two equations with opposite reciprocals, then that has to be perpendicular. Two equations that aren't related in any way, or two slopes that aren't related in any way, like these two, then they aren't parallel or perpendicular. All right, let's look at the next page. Indicate whether the lines are parallel, same slopes, perpendicular, opposite reciprocals, or neither. All right, so we need them to be in slope-intercept form, which means that any of them that aren't solved for y, we have to solve them for y. And we're going to try to do that quickly. So this one is solved for y. See, y is all by itself. So this is y equals mx plus b. And the plus b is missing. That would mean it has a y-intercept of 0. But that's okay. We just need the slope right here. So this slope is 2. This one we need to solve for y in order to be able to see the slope. So let's do that. So we want y by itself. So first you're going to subtract 5 from both sides. These are not like terms, so you can't combine them. And then we're going to divide off the 3. And when you divide one thing, you divide all things. All 3 terms must be divided by 3. It's distributive. You have to divide every single term by that number. All right, so this is going to be 6 divided by 3 is 2x minus 5/3. I know that's not real pretty, but that's okay. We're going to leave it that way. Equals y. If you don't like that, if you really like to have your y listed first, you can write y equals 2x minus 5/3. There you go. All right, let's identify our slopes. The slope here was 2. The slope here is 2. Same slopes. These are parallel. Okay. Next. Again, you got to solve for y. We're going to have to do that every time. So subtract 2x off both sides. These are not like terms here, so you can't combine them. List your x first, because that's how we want it at the end, right? We want our x listed before our y-intercept. Divide through by -5. Divide everything through by -5. And you get y equals negative divided by negative, so that's 2/5 x minus 2. All right, the slope here is 2/5. Next one. Subtract 10x from both sides. You get 4y equals, list your x term first. Divide everything through by 4, every single term by 4. Y equals, all right, simplify your fraction here. You can divide them both by 2, so you get -5/2 x plus 5. The slope here is -5/2. Now compare your two slopes. 2/5, -5/2. Opposite, reciprocal. So opposite and flip, these are perpendicular. All right, next one. Again, move your x over to the other side. 3y equals -4x plus 63. Divide everything through by 3. And you get y equals -4/3 x plus 21. And the slope here is -4/3, the coefficient on x. All right, let's do this one. Subtract 12x off both sides. And you get -9y equals -12x plus 21. 27. Divide through by negative 9. Divide everything through by negative 9. And you get y equals negative divided by negative is a positive. Simplify these by dividing them both by 3, and you get 4/3 x. Positive divided by a negative is a negative 3. And identify the slope. Well, those are attractive, aren't they? Those are very similar. Negative 4/3, positive 4/3. They're opposites, but are they reciprocals? And if less, they either have to be exactly the same to be parallel, or they have to be opposite reciprocals to be perpendicular. This is opposite but not reciprocal, so this is neither. Those two lines are not parallel or perpendicular. All right, let's take a look at these. So in algebra, we looked at x equals 4 and y equals negative 2. This is in slope-intercept form. There's no x, though, here. You can see 0x, which means it has a slope of 0, and a slope of 0 is a parallel line. Your little car traveling left to right is not going uphill or downhill. It's just staying even. That's a slope of 0. So that's a horizontal line. And x equals a number, that's the other one. That's the vertical line that has an undefined slope. This isn't even in slope-intercept form. You can't write it in slope-intercept form because it doesn't have a y. That's the exception to our rules here. So this is a vertical line where every x coordinate is 4. So watch. 4, 0, 4, 1, 4, 2, 4, 3. Every x is 4. That gives us a vertical line. Okay. In this is a horizontal line, and all of our y coordinates are negative 2. So doesn't matter what x is. X can be 1, y is negative 2. X is 2, y is negative 2. 3, negative 2. 4, negative 2. Okay, so this is a horizontal line where x is negative 2. Well, if you have a vertical line crossing a horizontal line, they form a right angle, and these are perpendicular. Okay, last one. Write the letter of the appropriate equation in the column. Okay, so a line parallel to this. Okay, here's our slope. We want one that has a parallel slope. A line perpendicular to y equals 4. A line perpendicular to, oh, and this is a horizontal line. We just looked at this. Let's go up here. Do you see a vertical line? We're looking for perpendicular to a horizontal line. That would be a vertical line, and there it is. So we already know that one. Yay, we're done with that one. Perpendicular to, we're going to have to change that to slope-intercept form, and parallel to this, we're going to have to change that to slope-intercept form as well. All right, let's look at this one first because it's already in slope-intercept form. Parallel to this means we're looking for a slope of 3/5. Okay, this does not have a slope of 3/5, and it's in slope-intercept form. That's a slope of negative 1/4. So that one's off the table. This one and this one, these are only two possibilities for this, for having a slope of 3/5. And this looks favorable. Let's change this real quick, see what comes up here. So let's subtract 3x from both sides. We get negative 5y equals negative 3x minus 30. Divide through by negative 5. There it is. And we get y equals 3/5 x minus 6. So this is it right here. That's what we were looking for. 3/5. It matches. So that's C. All right, a line perpendicular to 4x plus 2y equals 12, or parallel to 2x plus 8y equals 7. I like parallel better because the slopes are exactly matching. So I'm going to do this one first and leave that one for last. All right, change this to slope-intercept form. This should be getting common to you now. 8y equals negative 2x plus 7. Divide through by 8. And you get y equals negative 1/4 x plus 7/8. All right, so this one has a slope of negative 1/4, and we need to find one that is the same as that. And there it is. That's B. Let's use a different color. B. Oh, already had that color. All right, last one, perpendicular 2. So all we're really doing now, because we've already used all of these, is checking to see if this will work with this one, okay? So let's do 4x plus 2y equals 12. We'll change that really quickly. I'm going to start skipping some steps here. I'm trying to get 4x over to the other side. I do it by subtracting 4x. Do you see what I just did? Oop, it's gone. And now divide everything through by 2. And you get y equals negative 2x plus 6. All right, this one has a slope of negative 2. I'm looking for this to be perpendicular to that. So perpendicular, opposite and flipped would be positive 1/2. This needs a positive 1/2 slope. Let's check. X minus 2y equals negative 2. Subtract x from both sides. So it's gone. Divide through by negative 2. And you get y equals negative divided by negative is positive 1/2 x plus 1. All right, there it is. This is opposite reciprocal. So it is what we were looking for, and that means that this is D right there. There you go. All right, done.